I don't know if you've ever thought about how a building works. Let me talk about all the parts of a building since we're going to talk about structural analysis. You stand on what you call the floor, but we call it a slab. Okay? The slab is connected to these tiny little beams underneath it, and those are what we call joists. Smaller beams we call joists. Now, these joists, they go like this, and they connect to bigger beams going this way, and we could call those beams. Those beams could then connect to maybe something even bigger, and we would call those girders. So in the hierarchy of size, they're all beams, but we call it joists, beams, and girders. They're all things that we are drawing in this class to look like this. Joists, beams, or girders, just depending on the size. And the part that goes on top of these things, so let me draw it in 3D. So here we have two joists or beams, and the part that goes over it that you actually stand on, we call that the slab. What keeps the whole system in the air are columns. Okay, so these are called columns. And usually the columns are connected to the girders. So it goes, slab is connected to the joist, joist connected to the beam, beam connected to the girder, girder connected to the columns. Finally, the whole thing has to stand on the ground, and all the weight is in these columns, and these columns are like nails. You're pounding them into the ground. They would just sink into the ground. And so that they don't sink into the ground, you put these giant footings under them. And you can think of footings as like snowshoes. If you were to step in snow, you would make a hole. And we call it post holing, because it's the same thing. If you put a post in the ground, it will sink in. Well, if you don't want to sink in, you just need a bigger area, so you would wear a snowshoe. Okay? And that area, this extra area, would allow you to stand on the snow without sinking in. In the same way, think of the column as your foot or your leg, and think of the spread footing down here as a snowshoe, and you're spreading the load out over the soil so that you don't sink into the ground. In fact, one time I was evaluating a transfer student from Latin America, see what courses he had and see what courses we give credit for. And he had a course that I wouldn't give him credit for. And he asked, why am I not getting credit for this engineering class? And I said, you are not getting any credit for a course called shoe design. That's just not part of civil engineering. Why should I give you credit for shoe design? And he said, shoe design, yes, it's at the bottom of the columns. And then I realized they had mistranslated footing to shoe. And that's actually what made me think of snowshoes. From then on, I think of footings as snowshoes. But anyway, that's what a footing does. Another way you can support loads, especially like walls, is called a wall footing. So you make a not so wide, but it's really long, and it goes under the wall, and that's enough area to stop the wall from sinking into the ground. It's good for you to know the names and parts of a building if you're going to be a civil engineer or architectural engineer. But for this class, what you really need to know is what kind of forces are on the different parts of the building. And so the different kinds of forces that can go on a building is axial load, when you push along the axis of the member. That's why it's called axial load. Bending, so when you put moments on both sides of something like that, it's going to bend like this. Can you see that? Take a plastic ruler and you put two moments on it and it'll bend like that. And then you can combine them or have both. This is important in terms of the behavior. Most things are very, very strong in axial and very, very weak in bending, but the bending can't be avoided. Actually, it can't be avoided usually, but there are certain kinds of structures where there is no bending, and we'll talk about that. So let's look at this building again, the parts of the building, but now in terms of what they're doing. The slab, so you can think of the slab as going over the joists. The slab bends. When you stand in the middle of the slab between the joists, you're making it sag. The joists, okay, so the joists that are going like this, they bend like this, so they bend. And finally the beams, which are going this way, they're a little bigger, they're just bigger joists, and they are bending. The columns, however, okay, so the columns are an axial. However, if you combine the gravity loads with wind, and so remember, wind pushes sideways like this, or earthquake, you can get in columns, in addition to the axial, you can get moments like this due to the sideways forces, or what we would call lateral forces.